So this week deals with probability distribution. And I've actually already gotten a question about how do we know what the probability is if we don't know how many flights there were to begin with. And probability distribution deals with the likelihood that something could exist. And so we don't actually need to know, if we knew how many flights were previously tested, that would give us the percentage of flights that existed, but it wouldn't give us the probability of what could happen. So probabilities are used in operations, finance. They're used in a number of different business functions. This is probably one of the most useful pieces you're going to get out of the class, is how to calculate probabilities. There's a few different methods to doing it, and I think the biggest challenge is really identifying which method to use, and that just comes with practice and almost memorizing the types of situations that each of these use. So we're going to do, the first one is factorial, so solving probabilities with factorials. Factorials are like really weird to me. Factorials are numbers followed by an exclamation point that indicates it wants the factorial of that. So a factorial of 0 is always 1. We know that.
Okay.
The factorial of 1 is essentially 1, because you'd be 1 times 1. The factorial of 2, again, it goes back to the beginning of the number line, so it's essentially 2 times 1, which is still 2. Now we start to get into, after 3, we start to get into some differences. So the factorial of 3 is 3 times 2, and ultimately times 1, but we leave the 1 out when we're identifying factorials because it's always just going to do nothing to the multiplication. So 3 times 2, which would be 6. The factorial of 4 is 4 times 3 times 2, which is 24. So then the factorial of 5 is going to equal 5 times 4 times 3 times 2. So we take each one, which equals, let me do that one real quick, times 4 times 3 times 2. So the factorial of 5 would be 120. Now we can also do the same thing in Excel with the fact function. So equals fact. Maybe we don't want to go through what if we had a factorial of 100. That would be horrific, right? So we can just put in the number, factorial of 5. It's 120.
Huh.
Right? We love Excel for that.
Okay.
So when we have a probability and we write it as, in this particular case, we know that 27% of the flights were delayed. And we want to know what the probability of 5 randomly selected flights would be all delayed or not delayed at all. So we write that as, what's the probability that X, as in the number of flights that were selected, equals 5. So in other words, what's the probability that all flights, all 5 of the randomly selected flights are delayed? So we write that P, the probability, P, X equals 5. Now the handwritten formula for calculating the probability is going to be the factorial of 5 divided by the factorial of 5 times the factorial of 0, because we have 5 flights and we want to know it's either 5 or 0. All 5 flights are delayed or 0 flights are delayed. And then the percentage of flights that are delayed to the power of how many flights we want to know with the probability. So in this case, it's 5.
Okay.
So this tells us 27% chance to the power of 5 flights being delayed. and then 73% chance to the power of 0 flights being delayed. That's just 1 minus 0.27. So the opposite. Excel is so much nicer to us. If we take just this piece, this factorial piece, and I break the equation out because otherwise you get so many parentheses and brackets in Excel that you could end up just losing yourself into what brackets go where. So I took just this front piece. And the factorial of 5 divided by the factorial of 5 times the factorial of 0. Well, if we look at what this would actually be, we know the factorial of 5 is 120, right? And so then the factorial of 5, so 120 times 1, because the factorial of 0 is 1, is 120. So 120 divided by 120 is 1. But if you were to write it out, you could, or if you were to type it out, you would do equals fact 5 divided by fact 5 times fact 0. And you would get the same 1. But in this case, and putting the formula in there helps so that we know if the situation were different, for example, we could still have the formula. And then I took the second piece of the equation, this last half here, and I typed it out. And we can use to the power, which is just Shift 6 on a keyboard in Excel. So I said, I want to take whatever this solution is, so equals C4, times 0.27 to the power of 5 times 0.73 to the power of 0. And so there's our solution. The probability of all 5 flights being delayed is 0.00143. Or in percent format, it would be less than, it'd be 1.43%. So we do the same thing for the probability that no flights will be delayed. And it's the same factorial. The only difference is that now we're going to do 0.27 to the power of 0 and 0.73 to the power of 5. So we can actually take this and copy it down. But we want to make sure that our factorial piece of that equation, this piece is pointing back to the same thing. And we're going to change this to 0. Change this to 5. So there's roughly a 20% chance that all 5 flights will be delayed.
Okay. I get where we get the 0.27 because of the 27% of the domestic flights.
Mm-hmm.
Where do we get the 0.73?
So there's a 100% chance that either none of them will be delayed or all of them will be delayed. So, or somewhere in between. So 100% minus 27% is 73%.
Gotcha.
So that's with factorials. So anytime you see that factorial symbol, just know that 1, you can do it in Excel with fact. So you can just find the fact. And 2, this is what it's doing. It's multiplying it by every number that comes before it.
Okay.
And so this is solving probabilities with factorials. And again, I like to break out the equation so you don't get lost in all of the parentheses, but you don't have to. Excel can do it. The key to Excel, and particularly in handling Excel with statistics, is to tell it what you're looking for. So if you think of the equal sign as being, and I'm going to put a apostrophe here so that it doesn't think I'm actually typing a formula. Equals is I want, or it is I want to know. And then the remaining part, the formula, is telling it what you want to know. So in the case of a factorial equals fact, I want to know the factorial of, and then the parenthesis means whatever it is that you want to know the factorial of. Okay. 120. I'll make this bigger. So the next one, oh, go ahead.
Sorry, on the other question, the previous one, the C4, there was a cell where we timed C4 to the other numbers, but on the C4 we actually had text instead of numbers. How did we time that to the numbers?
C4?
Yeah, there was a sheet. Where did it go? Right here on the 9, C9. You see that, the 0.00, and then equals to C4 times by...
I put a hypostrophe here to show you what formula was in this cell.
Gotcha.
So it's actually, because I moved everything down, sorry, it's actually C8. I had moved everything down when I was typing, so...
And this is exactly how you want it when we do the questions. It's from that cell, like, for example, from a cell, let's say C5 down to C12.
Exactly. So as long as you put in, and you can put as long as you put in what it is that the solution is for. So this would be part A, and then you'd put the probability of X to 5, and then this. So you really only need this piece here, as long as there's a formula in here. And I can click on it and see that there's a formula in there, and that you typed the formula incorrectly. And the other reason why I have you do that, aside from just showing your work, is that it enables me to see if there was an error, if it was just a typo error, or if you are typing it in incorrectly altogether. So let's say, for example, you accidentally hit, fat fingers hit to the power of 6 here. I could say, oh, I see where you went wrong. You did to the power of 6. It should be to the power of 5. Otherwise, it would have been correct. And then I can give you full points for it.
Gotcha.
Okay. So as long as you have, if you have on this tab problem 5-89, and then your name, all of the other stuff you don't have to have.
Okay. I did that part, see where the sheet goes. So on the sheet and sheet 3, that's where I did. What problem I did, my name and everything, and then on the top I just had the problem.
That's fine too.
Okay, perfect.
As long as the tabs do. So this one would be problem 5-91. And so this one deals with mortgage holders. So let me grab the language from that. Hold on just a second. I made it way too big. There we go. Okay, so in this case we have 100 randomly selected mortgage holders. We know that 20% of the mortgages were underwater as of 2009, where the value was owed more than the value of the home was less than what was owed on the mortgage. So what it wants to know is what's the probability of X. So the number of mortgages out of the 100 randomly selected will equal 15. So what's the probability that 15 of those homes of the 100 will be underwater? What's the probability that the number of homes underwater will be greater than 20. And what's the probability that the number of those homes will be greater than or equal to 25? And this piece uses this one uses solving probability with binomial distribution. And this is really cool because watch this. We love Excel for this. binom.dist. So what's the number S? So in other words, what's the number that we want to know the probability of? And we want to know if the probability is 15. So we're going to put 15. How many trials were there? There were 100. What was the prior probability? So it was 20%. So 0.20. And our cumulative. Do we have cumulative distribution or a math function? So we put either a 1 or a 0 here, and in this case we're going to use 0, and we hit enter. Right?
Perfect.
We love Excel for that. So I'm going to put this as the text here. And for the next one, it's a little bit different because we want to know the greater than 20. So we're still going to do, our binomial distribution. Just a second, switch screens here. So we're still going to use our binomial distribution function, and we're going to do 20. Oh, helps if I finish the function. binom.dist, 20, comma 100, comma 0.2, 2. See, I have fat fingers too. But this time we want to know the greater than. So we want the math function. So we're going to type in a 1. So the probability that it's going to be greater than 20 is 0.55.
Okay.
Oh, sorry, that's the probability that it will be 20 or less. So in order to get the probability of greater than 20, x is greater than 20, we need 1 minus the 20 or less. Oops. Equals 1 minus this. So this is our probability that it's going to be 20 or less. So the opposite of that, greater than 20, would be 0.44. So 1 minus that. So let me put, I'm actually going to move these over. And make sure the text is in here. There we go. So this is actually going to be our answer for greater than 20. So now the probability of greater than or equals to 25 is going to be a little bit more of a challenge. The greater than or equals to 25 is also going to be a 1 minus. So we know that the probability of X greater than or equal to 25 is also equal to 1 minus the probability of X. Man, I really can't type today. I'm trying to type and read at the same time. X less than or equal to 24. So the reason we use 24 is because we want to include that 25. Up here, we were just doing greater than 20. But now we need greater than or equal to 25, which means it basically has to be the opposite of greater than or less than or equal to 24. So we want to include that 25. So we still use the binomial distribution function. And now we're at 24, 100, 0.2, and again 1 because we want that less than or equal to. And then we're going to do 1 minus. So the probability of X being greater than or equal to 25 is 0.13. So here, this is the probability that it's going to be less than or equal to 24. So everything above that is 1 minus that.
Okay, perfect.
Right? We love Excel and all of the lovely functions that it does.
Yeah, you're saying it very clearly, so everything makes sense.
Good, thank you. All right, so let's grab the next one. And the next one I wanted to do is 593. And won't let me copy it now. It went away. So in problem 593, it says that bats can consume, on average, 10 mosquitoes per minute. And it wants to know what's the probability that it will do 4 mosquitoes. So the probability that it will consume 4 mosquitoes in 30 seconds. The probability that it will does not consume any mosquitoes in a 30-second interval.
0.
Yeah, X equals 0. And the probability that it will consume at least 1 mosquito. So the first thing we have to do is convert the number of mosquitoes to 30-second intervals instead of 50 or instead of 1-minute intervals. And so that's just going to be our 10 divided by 5. And divided by 2. see, it's been a long day. I'm sorry. 10 divided by, I was like, that, no, it's 5, not 10 divided by 5. So it's just 10 divided by 2.
Where do we get the 10 by?
Because it consumes 10 mosquitoes per
10
minute,
mosquitoes per
and there's
minute, okay.
2 30-second intervals in a minute, so a 30-second is 5.
A 30-second is 5. Okay.
Mm-hmm. So our 30-second intervals is 5. And now we're going to solve probabilities with exponential distribution. And so we know that it's exponential distribution because it asks us, I think it says somewhere in the problem that they're exponentially distributed, but in this case, we know that they're exponentially distributed because it's an average, so we know we need to use exponentials, or at least we're learning now that when it's an average, that we're going to use exponential distribution. So the equation is actually written, so if we wanted to know equals 4, we would do e to the power of -5 times 5 to the power of 4 divided by the function of 4, or the factorial of 4, sorry. In Excel, we can do exponents or exponentials by using EXP. So we can actually type this equation exactly the way that it is. We want to know the exponent of -5 times 5 to the power of 4. Divide that whole mess by the factorial of 4.
Okay.
So whenever we see E, it equals the, in Excel is EXP.
Okay.
Exclamation point is fact.
Factorial. Yeah.
Mm-hmm. So then if we wanted to know the probability of x being 0, we would do the same formula, only instead of to the power of 4 and the factorial of 4, we would use to the power of 0 and the factorial of 0. So we're going to copy the same formula, and we're quite literally just going to say to the power of 0 and the factorial of 0.
Okay, same formula.
Mm-hmm. Same formula. And on this last one I actually have incorrectly. It should be to the greater than or equal to 1. So it's going to be, so again, just like we did with the last one, greater than or equal to is the same as saying 1 minus less than or equal to 0 in this case because it's the number below it. So we just need 1 minus equals 0. So I'm going to pause this for just a second. And I'm actually going to, with Chapter 6, uses slightly different information or slightly different ways in order for us to find these probabilities. So in this case, it's using mean and standard deviation, which is part of chapter, or the first 2 chapters that you did. Mm-hmm. So these two kind of stack onto each other. In this case, the top 10% of exams are admitted to a program. We know that the scores are tested normally distributed, normal distribution, with a mean of 420, so an average of 420, and a standard deviation of 80. So when I read these problems, I like to just break out the key pieces of information to help me figure out what I need to do and what I need to solve.
Okay.
So in this case, the formula is going to be, if we want to find out the minimum score you must earn to get admitted, so the top 10%. So we want to find out so we're going to use x equals the mean plus the z score, which I'm going to show you where we get the z score, times the standard deviation. So for the z score, we know that if she wants to be admitted, we want to find out big Z is less than little z equals 1 minus 0.10, which is going to be 0.90. So we're just finding out if we want to know when that is less than the 90% or when it's less than the 10%. So we're going to look at the 90% of the scores that wouldn't be admitted as far as the Z table goes.
Okay.
So we're going to flip over to, and I need to share this part of my screen. So we flip back over to this table that is in the back of your books. And we read z-scores this way. So a z-score is the distribution or the portion that is less than where we want to be. So we want to know the top 10%. So we're looking at the 90% to find out what the score is for that so that we can calculate the formula for the top 10%. So we know we're looking for 0.90, and we kind of just have to look through this table and we see, okay, it's somewhere between here, 0.89997 and 0.90. So we're going to round our z-score to the first two decimals. So in this case, we're going to take this 0.8997. So it's 1.28.
1.28.
Because we have 1.2 here. And we have 0.08 here. So the z-score that we're going to use, so z equals 1.28. So now we can do the rest of our formula because we know that it's going to equal our mean plus our z-score times our standard deviation oops, put brackets in it, didn't like it. Why? Oh, because the z isn't actually a number. Wow. 1.28. So we know that she needs to get a score of 522.4 in order to be admitted.
Okay. That was it?
That was it. Right?
That was good. It just sounds complicated.
It sounds complicated. It sounds way more complicated than it is, especially when you're using Excel. All right, so let's take a look at 685. And we don't have to look up those Z's anymore, although you will in later problems. So find that page in your book and tab it.
Okay.
So now we want to find an average of IQ scores normally distributed. So this gives us an idea that we're going to do normal distribution. And we want to find out, it has a mean of 100, so let's put that information in here. The mean is 100, and standard deviation is 16.
Your paused.
Oh, standard deviation is 16. There we go. And now we want to find out what's the probability that it will be less than 80, the probability that X will be greater than 125, and what is the probability that they will be in the top 2.5%. And my computer doesn't have the little sigma symbol, so we're just going to type that one out. 25%, because I can't put a sigma symbol. I can't even say it. Sigma symbol. Okay, so we love Excel again because we do this. Equals norm.dist. What's our X? In other words, what are we trying to target? And that's 80. Our standard deviation. Or sorry, our mean. Let's go back. Our mean. Our standard deviation. And is it going to be cumulative? Yes. So the probability that a score will be less than 80 is 0.105 or 10.5%.
Can it be greater than 80? No, less than. Okay, so whenever it's less than, we can put a 1 in there.
Whenever it's less than, that's when we can just use normal distribution without doing a 1 minus. So in this case, we're doing greater than. So this is going to be equal to, it's going to use the same formula, but we're going to do 1 minus this. So we're going to do 1 minus normal distribution of 125 because we're looking at greater than 125, and so we want to, because normal distribution will give us whatever's less than 125. Okay. So we want 1 minus that, the opposite. 1 minus norm.dist. And again, we're looking at 125, the standard deviation. And this is the other reason why I like to, I did it again, the mean, the standard deviation, and then cumulative is 1. The other reason why I like to type out the information is so that I have it available to me to just click on the cell. So if I did something, I had a typo or something, I can just change this. So maybe I read the problem wrong and it's actually 17.
Yeah.
And so the difference now, if we wanted to find out the top 2.5%, we use a normative inverse formula, but again, it's going to be, it's going to give us the less than. So we want the top 25%, so, or 2.5%. So first we figure out 1 minus 0.025, which equals 0.975. So now we can move that down here. So now we can do the formula norm.inv. And the probability that we want is 0.975, our mean, and our standard deviation. I'm gonna pause. So in order to be in the top 2.5%, someone would need to have a score of 131.6.
Okay.
There we go. So it's giving us the actual score and not a probability. So I wanted to make sure I clarified that in the notes. So this would be the score that would achieve a top 2.5%. And there's only one more. And it actually is probably the easiest one, I think, but this is 6-87, and I will turn my screen on. There we go. So the first thing we want to calculate is the rate parameter on this one. And the reason we want to is, again, just like we did with the bats, we have to break it down so that it's the same as what we're calculating. So it wants to know in minutes. So we need to break down how many are in 1 minute versus the 15 minutes. So in this problem, it says that we have a distributed mean of 15 minutes, that feeders are exponentially distributed. So we know we're going to do exponential distribution, just like we did with the bats. So our rate parameter, if we're at 15, one car every, or mean of every 15 minutes, we're going to do 1 divided by 15. So we have 0.0667 per minute.
Yeah, my son wants ice cream.
Ice cream. Ice cream.
Oh, wait, Mommy.
So for exponential distribution, and this one's actually pretty quick, so he'll get his ice cream soon.
No, he's going to go to bed soon.
Uh-oh. So they wanted to know 2 different things. One is what's the probability that it will be less than 10 minutes that a feeder will come by, or greater than 25 minutes. So at the greater than, we know we're going to do 1 minus because we want to know the opposite. The function will only give us the less than. So less than 20 minutes, the function is going to be, we use, whenever we see e, again, it's exponent, so it's equals the and I know this sounds weird because we're actually using 1 minus, but the next one's going to be 1 minus 1 minus. So the formula for the less than is 1 minus exp, the exponent of whatever our rate parameter is. So in this case, 0.0667 times 10. So we're going to type in that function this way. 1 minus the exponent of 0.00, or actually we're going to click on the cell, times 10. Oh, negative, sorry. Your exponent has to be negative. It's like I knew I typed something in wrong there. Negative B6. There we go. So there's a 48% chance or 49% chance that a speeder will come along in less than 10 minutes. So then the opposite of that, because we want greater than, we're going to do the same formula, but our exponent is going to be multiplied by 25. And we're going to do 1 minus this formula. So again, 1 minus minus. So in this case, and I have another class that's joining us, so they're going to kind of be sitting tight here for a second. So we're going to do this formula. We're going to copy it in. We're going to do 1 minus, change this to 25, and make sure that we move this back up. And so we have an 18.88% chance that the speeder won't come along for more than 25 minutes.